So I work for a company you may have heard of called Microsoft. We're trying to be the next big thing again. I've been with Microsoft for 12 years, so I've been with the company long enough to see some interesting ups and downs. And my role at Microsoft, you might say, what does a senior technical evangelist do? My role is to try to create interest, create awareness first of all, create interest, and hopefully spur people on to actually use some of the new technologies that we have, whether it be languages like TypeScript or programming environments like Visual Studio, or even building for our latest platforms like Windows Phone and Windows 8. Today we'll actually be talking about TypeScript. So just to start things off, JavaScript is fantastic. Functions, closures, the dynamic language, the expressive way you can write code in it, they're all fantastic. There are some things in the language, though, that we wish we had. And when we talk about TypeScript today, we'll see that we've kind of put a standard approach to doing things that aren't radically new. So if you say, well, classes, they're not new, and inheritance, that's not horribly new, and modules, they've been around. That's true. But what we'll see when we get into TypeScript a little bit more deeply is the fact that we kind of have a standard approach for doing this. So just to be completely clear, JavaScript, I like it. It's awesome. It's good. But one of the things that a lot of people will tell you is in large-scale JavaScript development can be hard, right? Now we're talking, when I say large scale, we're talking 20,000, 50,000, 100,000, 200,000, 300,000 lines of code. It's probably hard in any language. But in JavaScript, it can be particularly hard because some of the things that you might expect to have in a language that you might see like in C# or Java, like namespaces, yes, they can be implemented in ways, but they're not part of the core language definition itself. The language is incredibly flexible, dynamic, and incredibly flexible so you can define them, but they're not part of the language itself. And so these items here, they're not directly from me. They're from a team within Microsoft that has a 150,000 line JavaScript project. And these are kind of what they surfaced as their concerns. And they actually use TypeScript underneath the covers now. But if you are familiar with Eric Gamma of the Gang of Four, the whole patterns idea, he actually leads this team. And his team is building a project or building out a project called Monaco. And this came from his team. So one of the challenges of dealing with large code base, large and growing code base in JavaScript is the need to come up with these kind of patterns, right? There are certainly approaches to classes and to modules and to namespaces. One of the challenges is, frankly, there are so many approaches to classes and modules and namespace, and each of them has their own uniqueness where you say, oh, this one's got traits, that's kind of cool, I'd like to use it. And one of the things that they saw in their code base was they had to think up front about how they're going to structure their code. And one of the challenges for them really was in how they actually structure that code, right? They started out very dynamic, moving their code base along, making great progress. But what they saw is when they reached 20,000, 30,000, 40,000 lines of code, things got significantly harder for them to manage. One of the other things, and I think this is true of any language, so I'm not trying to offend anyone, so refactoring JavaScript code can be difficult. Any programming language rots over time, right? There are changes in the core language, new facilities, capabilities become available in the language, and you say, hey, I want to actually start to use them. And so we have to actively kind of refactor our code. One of the things that a group of developers in this team said was that with JavaScript projects, it's kind of like carving code in stone, because when you get to 50,000 lines of code, when you want to refactor, it becomes particularly challenging, right? You have, let's say you want to search for something called name. Well, it could be a parameter, and it could be a local variable, and it could have global scope, right? And so just doing a massive kind of search and replace isn't necessarily a great way to handle it. Yes, you, I'm sure, are disciplined and you have unit tests, but still there's some challenges to that. So refactoring code can be hard, and this team actually saw that in Internet Explorer. There's what we call the F12 tools, and those are tools that essentially help you look at traffic going between you and the browser, as well as let you do debugging on your JavaScript application. And they were writing the editor that lets you look at the code in there, which supports minified code. And so for them, it became this moment of, okay, we've got to significantly change the editor, refactor our code base, because now we're going to support these very, very long lines. And they were really happy about the fact that they used TypeScript. I'll show a little example of that in a minute. that they could use it to safely refactor because it understands the difference in scope of the variables they had declared. Finally, one of the things they talked about was kind of the APIs themselves. It can be a challenge keeping the APIs in sync. When you have documentation that's separate from the code, right? Anything you can get closer to the code, the better. Anytime you have anything separated from the code, the implementation from the actual documentation, it can make it harder to keep the APIs in sync, and that's one of the things that they saw as they were doing their development. So what is TypeScript? The marketing slogan, I guess, is the language for large-scale JavaScript development. Doesn't really tell you much about it. Let's dig into that a little bit further. It is essentially a typed superset of JavaScript that compiles down to plain JavaScript. So one of the things that's interesting about this, I've had different people ask me like, hey, is this some kind of embrace and extinguish thing? No, JavaScript is the language of the web. We get it at Microsoft. We are writing our own tools, some of our own tools in it. So Project Monaco is a browser, and imagine Visual Studio, but imagine it running in a browser. That's kind of what Project Monaco is trying to approach. So we are users of JavaScript. You can actually write JavaScript, native Windows 8 apps using Win.js. So we're big users of JavaScript. The cool thing about this is, if you think about why do you like JavaScript, the reasons you like it is well, there's a number of reasons you probably like it, but it runs in any browser, any host, any OS, kind of runs anywhere. It is the language of the web. And the cool thing about TypeScript is we don't actually stop you from doing that, right? It essentially is, let's flip back a slide here. At the end of the day, when you run the TypeScript compiler, TypeScript is really a design time illusion, if you will, that gives you strong typings while you actually are doing development. When you run the compiler, it actually makes them all go away, and out the other end just shoots JavaScript. So it is completely JavaScript compliant. It is JavaScript, actually. So TypeScript wants to help. We saw those challenges earlier we talked about by providing optional and structural typing. So what we'll see here in the examples that we look at is that providing a few annotations, you can very quickly start to get some benefits from typing. Not that classes and modules are unique or new. We didn't think of them, not saying we did. But what we try to do is formalize them in the language and what actually gets produced. And what we're doing with respect to classes and modules, ECMA 6 standard is looking to be ratified in December of 2014, and we're actually aligned with it. And the next release of TypeScript, which is going to be either 1.1 or 2.0, depending on what they decide to call it, is actually all about getting TypeScript to be directly aligned to the ECMA 6 standard. Additionally, there's interfaces which allow us to name object types. And what you'll see is that, yes, we can explicitly implement an interface. If you're familiar with Java or you're familiar with C#, you may be familiar with those types of concepts. But what we'll see is that, yes, I can explicitly do that in JavaScript, but I can also kind of let it just figure out from the shape of what I've described that it's an interface, and we'll see how that actually plays out. So JavaScript clearly has a type system. It's just not manifest till runtime. What TypeScript is seeking to do is to make that type system visible at design time and coding time, and then, as I mentioned, it evaporates when you actually run the compiler. So in essence, TypeScript is a static formalization of the JavaScript dynamic runtime, and it essentially it espouses to take JavaScript the good parts, add strong typing to it, add tooling to it, and in the end you end up with just JavaScript. So if there's questions out there along the lines of, hey, this is kind of cool, is it only a Visual Studio thing? The answer is the TypeScript language itself is open source. The TypeScript compiler and tools, the language service, if you will, are open source, and they've been integrated into tools like IntelliJ and ReSharper as plugins that use it. So they're available to be used. You can pull them in. It is in Visual Studio, but it doesn't have to be used in exclusion of Visual Studio. And in fact, there's a commitment from the team with all the tools that are available in Visual Studio are actually available open source as well. So in my opinion, the cool thing about TypeScript is, if you think about TypeScript's type systems, in general, they're all in or all out, right? Take C# or Java, essentially you have a strongly typed system, and it's on. It's kind of binary. It's on or off, right? And then you look at JavaScript, you have a system which is incredibly dynamic, and essentially type system is only evidenced at runtime. What TypeScript allows you to do is essentially have a dial where you can say, yeah, I'm going to take some JavaScript, I'm going to throw it into TypeScript, it runs straight up. And then if I want to add some type annotations, I can do that. So the key takeaway, TypeScript, run through the TypeScript compiler, produces JavaScript. So some of the things that we'll take a look at here in the, I know you're like, get to some code, we'll do that. So some of the things we'll look at, structural typing and type inference. So yes, I can explicitly type something, and so I can tell the type. I can make an assignment of a number or a string, and so it can infer the type. But you'll actually see is that it does the TypeScript type system actually does a really nice job, or language service does a really good job of starting to infer types from what I've told it. It also allows us to work with generics. If you use Java or C#, again, generics essentially allow you to describe specific types and ensure that specific types are flowing in and out of parameters or collections and things. The cool thing, it works with existing libraries. And what you'll see underneath the covers is there's a file called whatever the library name .d.ts is, and it's essentially definite typing. And there are type libraries for over 400 JavaScript libraries, jQuery, Backbone, Knockout, Node, you can name them. But they are essentially, this is totally maintained by the community. It's not maintained by Microsoft. Finally, the cool part, another cool part, I guess, is the types. These types enable a good tooling experience, right? No, it doesn't allow you to produce perfect code. We can still produce, bad code in a strongly typed environment. But what it does do is give you some level of verification, some level of assistance, and from a tooling perspective, allows you to do things like statement completion, refactoring, and those types of things. So, is TypeScript used at Microsoft? Yes. So Visual Studio Online has about 150,000 lines of TypeScript code. They had an existing JavaScript implementation that they've actually ported over. And they took a kind of machine approach where they essentially wrote their own parsers, tore it apart, used some Java docs to create TypeScript. The Project Monaco team really started with TypeScript about 10% because they started coding about the same time as the TypeScript team started. And so they're all in now at 100% TypeScript and about 150,000 lines. And you can see their work. We'll see it in a number of places, but one of the places you'll see it is try WinJS. So WinJS is the JavaScript library that if you want to build native Windows 8 apps, you can use. And you can kind of see the Project Monaco project surfaced if we look at the CSS or the JavaScript view here, as well as the actual output controls. This is another thing that Microsoft has made open source and is available. And you see the source tab there. You can actually download it. So the actual editor experience that you see in HTML and the CSS and JS is actually provided by Project Monaco. So another interesting thing. The F12 tools behind Internet Explorer uses it. TypeScript Compiler, TypeScript language service, all written in JavaScript, or all written in TypeScript, which compiles down to JavaScript, and I'm sure the list goes on from there. So we're using it. So the idea that classes, these interfaces, modules, allow you to, it's not just about writing good code, it's about having structure to actually structure your code base. So classes, interfaces, modules aren't necessarily new ideas, but they're a standard approach to doing them. They're aligning with the emergent ECMAScript 6 standards, and it supports popular module systems like CommonJS and AMD type module systems. So this is not something we've rebuilt. One of the other cool things about this is when ECMA 6 is ratified and TypeScript supports it, you'll be able to flip a switch that says, yes, compile to ECMAScript 6, but by default it'll produce code that runs in a ECMAScript 3 browser. So you'll get all the benefits of the cool language stuff without having to have your entire code base and all your users, frankly, move. So from a community standpoint, the project is available on CodePlex, which is kind of our open source environment. There's 170 forks, some large number of feature requests, and we're actually taking pull requests now. We still are the maintainers of the TypeScript, or the shepherds, if you will, of the TypeScript language, but we're actually very engaged in the community about both feature requests and taking pull requests. On the framework side, I mentioned there's over 400 libraries that are available on Definitely Typed for Knockout, Node, jQuery, et cetera. And as I mentioned, since this is open source and it's something that compiles down to JavaScript, it's plugged into a number of IDEs, it's plugged into a number of build and execution environments, and it supports unit testing environments as well. So let's get to a demo. So I'm going to start with Visual Studio, and I'm just going to start with I'll do File, New File here. So I'm not going to start a project, I'm just going to start a new file. And I know that all of you would love to watch me type because that would be somewhat equivalent to watching paint dry. And as you can see how well I'm typing right now, especially when it's harder to type when you're standing than you think, so give me a little bit of credit. But rather than doing a bunch of typing, let me start with example here. So this is a sort by name function, and you'll see it takes an any, and we slice the any, so we could actually infer a little bit of what's going on here, but let's just go with it for a second. And so you'll see that we take an any in, and we have an any here, and we have an any that's returned. The result, of course, then is an any, and so you could argue that the function itself is returning an any. So we can't really tell you anything type-wise because, well, you haven't really told us anything type-wise yet. But let's actually start down the path of doing a little bit of work on the type here. So I'm going to tell it that I'm passing it an any array. And what you'll see right off the bat is now as I hover over slice, for example, I'm actually getting some information that could help with statement completion. So it's an array that I have, and so therefore the result is an array of any's that I'm returning, and the method returns an array of any's, so therefore we could say the sort by name actually returns an array of any's. So a little bit of type information. You actually have seen that we're able to flow that through all the way through this method, obviously not a giant method. If we actually look at the function of this method, what you'll see is that we're calling sort, and we're passing in two individual elements from that array and comparing them and based on their name property. So pretty clearly, if we try to use this without actually passing in a name property, we're not going to be able to sort anything. So let's take a look at how we could do something interesting with an interface that might actually kind of fortify this and ensure that what we're getting passed is what we expect and actually valid. So I'm going to start by saying interface here, and you'll notice the completion, it's kind of nice. And I'm going to call my interface entity. And I'm going to say that my entity, I'm going to say that my entity has a name property in it. And I'm going to go ahead and specify some type information here. So I'm going to say my entity has a name property, and it happens to be a string. Let's actually do an object literal here using that. So I'm going to say var e colon entity. So I'm telling it that it is specifically of type entity, and that's going to be equal to an object literal here. And what you'll notice is that I'm actually getting a little bit of feedback from Visual Studio here. What is it telling me? It's saying, hey, you're this interface. You've implemented this interface called entity, and that has a property associated with is called name. Okay, that's pretty nice. And you notice here I hit Control Space and I get auto completion. So it tells me there's this thing called name that I can actually use, and I'm going to say the name is equal to Bob. Good old Bob. Name is equal to Bob. There we go. Okay, so I could also go back and I could obviously add some other stuff to my interface. I could say there's a price associated with it, which happens to be a number. And you notice immediately that, almost immediately once I type things somewhat correctly, that my entity now is telling me, hey, you're not actually implemented correctly anymore. You also need a price to be associated with you. Thank you for letting me know that. You'll see my price is $5.95. So one of the other things that I could do is I could define an item called in stock, and I could say in stock is a Boolean. And of course, my object literal here will give me an error, but I could also do something like this and say my in stock is actually not required, it's optional. And then if I actually provide one, so if I say here in stock, look at that, autocomplete, love it. If I say it's equal to 100, for example, you'll see that I get an error. Why? Because it knows through type inference again, or by comparing it to the interface, that stock, it actually can't be a number, it needs to be a Boolean. So I can simply say, yeah, you're right, I'll make this a true, and then it's very happy again. Okay, so we've seen an interface. Let's actually see what we can do with this interface to improve our method here. So one of the things that we said was our method takes an array of any's, and we're using the name property. So you could pretty quickly argue if we don't have a name property on what we pass in, that it's not going to work horribly well. So I could say that instead it's going to take an array of entities in. And then you'll notice right off the bat then I actually get an error. Why? Because now it knows enough. Well, we told it a few things initially. I don't know if I showed this, but I know A is an array, so I can get all the array methods that go along with it, and I can select them. And as I actually select the method, for example, I can get all the arguments to go with it. So, okay, that's what that looks like, great. And you notice that it actually flagged the fact that I used local compare when obviously I meant locale compare here. So if I start to type, you'll see that the completion will, if I spell it anywhere close to being correct, will actually show me locale compare, and I could use that. So that's kind of nice. Oops. There we go. All right. So there's local compare. So my type system, has already helped a little bit. I've already kind of figured out a few things that were going wrong. Now let's actually try this out. So what I'm going to go down here and do is I'm going to say var p, our scale of our products is equal to, we'll make an array of them. And I'll tell you what, we'll cheat, because again, you probably don't want to watch me type. I know it's really impressive the way I type, but nonetheless. All right, so what I've got here is I've got an array of products, and you'll notice it happens to implement the interface. Now, I didn't explicitly say that these products implement that interface, but as we hover over it, you'll see that it kind of knows the fact that it's implemented. It has string and price, which are two pieces that interface. The optional in stock isn't there, obviously, because I didn't provide it in stock. And I also have some additional data, the ID. Let's actually see if we can get this to run. So what I'm going to do is grab it. I just opened a file in Visual Studio, but let's actually head over to the TypeScript playground now, because every language specification should have a playground that you can play in. That's kind of the new thing to do here. So I'm going to go over to the playground. I'm going to go ahead and get rid of what's in there, paste in the new code. Now I promised that this thing was actually making JavaScript, and you'll see it pretty clearly here that my interface is completely evaporated. Doesn't exist in the JavaScript side. And you notice that the type information, sort by name, telling it what type it was, that's completely evaporated. And so we're just left with just plain JavaScript. So that's what, in the playground, it actually takes what you type in on the TypeScript side and runs it through the TypeScript language service and compiler, produces JavaScript on the other side. So we're going to say var sorted is equal to sort by name. And that takes an argument of type entity. Let's just pass it products and see what it thinks about products. Okay. So you'll see here that it knows that we're passing in an item with these properties, name, price, ID. Coming out of it, you'll see that we've kind of lost something along the way here. We just know that it's an entity array that's returned, but we've lost the characteristics of what was in there. We'll get back to that in a second. Well, let's actually see if we can get this to run. That was kind of what I promised to do. So document dot body dot inner HTML is equal to, and let's say JSON dot, oops, JSON, boy, if I could type today, it would be dangerous. Note to self, try not to type as much next time. JSON dot stringify, and we'll actually pass it sorted. We will not give it a replacer, so we'll just send null, and we'll say that we'll use 4 tabs or 4 spaces there for spacing. And with any luck, we press run, and it runs. Okay, so there it is, and it's sorted by name. So hammer, lawnmower, pliers, screw. That's all good. All right, that's nice. What can we do to kind of rectify the fact that we started with a kind of detailed view of what we're passing in here, but what we end up with is just an entity array? Well, it turns out that's being driven by the fact that we're passing in an entity and we're losing something along the way. So we can actually use generics here to provide more type information. And now we can say it is sort by type T. So whatever object you give it, it'll actually make sure it implements that interface. And we'll say that it takes a type T as an argument. When I did that, what you'll notice now is it's complaining about name. Does it keep me from running it? No. One of the beauties of JavaScript is it tries to do the right thing and often does. But what it's telling me is, hey, name is actually something that is not going to be on, you said any object can come in here now, is what you basically told me. And in fact, any object does not necessarily have a name property. And it's actually right. So what I want to do is actually say that it extends t. So it keeps the t-ness that was there, or extends entity, I should say. It keeps the t-ness that was there, and in addition to that, passes it all the way through. So now if we look at this, going in, we know what it is. Coming out, we know what it is. If we were to come in here and change the name of one of these like that, so it's no longer, you notice right away the compiler is saying, hey, you can't actually, the parameter you supplied doesn't actually implement this entity interface that you told me you were going to implement. So that's kind of cool. Oh, one of the things I promised I would show. Let's say that I have a local variable called name here, and it's equal to ABC, or whatever I typed there. And I have a name here on entity, so obviously one has more global scope and one has local scope. If I, even in the TypeScript playground, if I come into TypeScript playground and say rename symbol, you'll notice that now I could say something like entity name. And it knows, notice it didn't change the local version of it here, it changed the appropriate ones here because it's that smart. So refactoring is a lot easier when it has that kind of scope and understands what the code actually means at some level. So let's go through one last example here. Let's go back to Visual Studio, and I'm going to go ahead and just get rid of that code, and I'm going to grab a generic SortBy. So this is meant to sort anything. So let's actually take a look. Can I slide this here? No. So basically what it's saying is SortBy takes any type, T, takes an array of those as a matter of fact, and it's going to take a callback which returns an any, and ultimately it returns that type, an array of that type. I slice it, and here's my sort. I'm going ahead and grabbing I'm calling the method that I was passed in to actually get the key of each of the items that I'm passed, and then I do a comparison and return them so I can sort. So here what I can do is I can say, and you may have noticed that's a lambda expression there. That's actually not something that is in the language spec, and you notice it's just replaced with an inline function basically. The interesting bit is that lambda expressions actually are implemented in some browsers, and they're targeted to be in the ECMA 6 language standard that's coming out in December. So you should be able to actually use them, and they should pass through if you have an ECMA 6, if you compile code for ECMA 6. So you'll notice that I'm getting a complaint here because now SortBy is saying, hey, you're passing me one of the things I need, but I also need this, the callback basically that I'm going to sort on. So I'm going to say x dot. Let's start by price, sure. And then we're going to display that sorted list out. So sorting on price, 95 cents up to $500, that looks pretty good. I should be able, of course, then to say that I want to sort on, let's say the name, sure, why not? And there I'm sorting by name. So again, TypeScript, everything we do in TypeScript at the end of the day comes out as JavaScript and runs in the normal JavaScript environment. Let's take a look at classes. So I'm just going to get rid of that. I can say class. We'll define a class point. And I can say that it has a x, which is a number, and a y that's a number. And you'll see it being generated in real time, so no surprise there. Once I've done that, I can actually say var p equals new point. And you'll see that we, in fact, can create a new instance of point. Always helps if you case it right. There we go, create a new instance of point. And those variables that I declared are available to me. So there's the x, we'll give it a value of 10. There's the value of y, give it a value of 20. Now, as good language designers and programmers, we're probably looking at this and saying, we really should use a constructor on this, Martin. What are you thinking? You're right, so I'll go ahead and pass those as arguments. And you notice now it's complaining because of the fact that we don't have a version of the constructor that takes arguments. Well, we can easily create that. So I can go back to here and I can say constructor. Always helps if you spell it right. Even better when you get completion there. And I can say that it has a x, which is an integer, pardon me, a number, a y, which is a number, and then I'll implement it quickly, very quickly. There we go. I can say this.x is equal to x. This.y is equal to y. No surprise there. I can define methods on it. Sure, why not? So I could say distance. And that's math.square root. Sure. This.x times, so I'm just going to make this up here for sake of time, this.y. And close that. There we go. And I can also do something that's kind of interesting. So in essence, x and y are public properties here. So I can just simply get rid of them. And in my constructor declaration, I can actually say, I want these to be public. And you notice on the generated code side, it goes ahead and does basically the same thing that I was doing, where I've got these as public properties now. I can also do something like this, which is actually not part of JavaScript. So you might be saying, that's interesting. So I've got a color, which is a string. You don't see anything yet. I believe you. But if I then say this.color is equal to red, you'll see that how do you do that? Well, you're saying, well, gee, Martin, I can go ahead and type it. Well, you can, but the editor is actually smart enough now that it's telling you, hey, that's not available to you. And I can go ahead and say, yeah, I know it's really there. I'm going to type it in anyway. And I can actually, you'll notice on this side it's actually generated. But you're getting an error out of the editor basically saying it's inaccessible because it's private. OK, so for the sake of time, I'm going to just grab some code and plug it in. So here's a more complete implementation of class. I don't know if it's actually more complete or not. Maybe I lied. Maybe it's the same. Control V. So a little bit more to it. It has a static that you'll see as well. But the interesting thing, I guess, now is let's say that we want to make this a module. So I can say module. And let's call it utils. And again, this is a playground. It's not really meant to be a full-on editor, but it does have features that are kind of nice. So I can just grab this chunk of code here and say format code. And format it. Nice. OK, now you notice that I'm getting an error down here, and you might say, well, that's because of the fact that it's now effectively namespaced, Martin. And you'll see, though, no, that's actually not it. It's still complaining. Why? Because I didn't export it. Now it's exported. So what you see on the generated side, if you looked at kind of the standard approach that people advocate for building a class, we followed that approach. This is the approach that they're pursuing in the ECMA 6 standard as well, so nothing horribly unique there. An interesting extension of this, I guess, if you will, is if we looked at, we're going to go ahead and export another class here. It's going to be point3D. And it's going to extend point. Oops. Put that back where it was. All right. Extends point. I guess I have to tell it it's a class. There we go. OK, and I need to give it a constructor. And it's going to be public x again. Colon number, public y. Y colon number, and public z. All right. And I got to give it a body. That's why it was not doing anything for me there. Back here. And looks like, oh, looks like I dropped a paren. That's why it's unhappy. There we go. Now what you'll see over here is we actually have, this is the only time you'll see TypeScript generate code that you didn't write. It's basically a 4-5 line helper for setting up the class, making sure the prototype chain's been copied, any static data that you've defined are actually copied. And so that's what those are there for. And I can say, all right, we'll go this route here. Rather than having me debug it. There we go. So you'll see our class, we basically call the super with XY, so the parent constructor, and then you see that kind of implemented in code. We pass in the super as an argument, and we go ahead and call it. So that's kind of how we handle classes. You've seen interfaces. You might be saying, okay, this is cool. You've kind of covered the browser-y kind of stuff, but what if we were to actually do something with this on Node? Let's actually look at that. So if I say file new, or actually file open, pardon me, and I'm going to open a file, I'm going to select server.ts. And this is a really simple Node implementation here. It's giving me an error here because it's telling me I need to compile with the dash module flag, which we will do here in a moment. This is the reference to the node.d.ts file. And so if I actually looked at, for example, create server, right-clicked on it, I don't know if I actually showed this, so let me actually show it. Go to definition. Here is the node.d.ts, and it shows me for create server the different create servers overloads. Well, there's only one. So create server here and the arguments that it takes. So that's where the typing information comes from. And as you can see, I'm working on Node here. If you're familiar with Node, I can just say http dot, and I get completion, which is pretty cool. So you can use a couple of different approaches to modules, CommonJS, or one of the AMD approaches. I also have a client that I've set up here. I'm going to go ahead and open that quickly. So file. While I'm here, I'm going to grab this directory, copy that directory, and I'm going to open the, can I get away with this? I'm going to open command, and I'm going to open hello.ts. There we go. All right. So we'll look at both of those. The client essentially imports the code I just wrote in the server. It creates an instance of that server and listens on the port. The server, if we actually looked at its implementation, goes ahead and listens and sends a message back and echoes the message that was sent to it. So, and if you look at the go command, basically it's just a batch file. It runs the TypeScript compiler, gives it the module flag for CommonJS, and then paths to where I have Node.js installed and runs it. So let's actually take a look at that. Oops. CD to, I already grabbed that directory. Oops. Unless I close it. There we go. I'm going to grab this directory here, and I'm going to paste it in there. It would have been really useful if I'd done a CD in front of that. All right. So I'm in this directory. There is, just to prove this, star.js. I'm going to go ahead and get rid of the JS files that are there, just so you can see that. Although from the distance you're sitting at, it might be hard. So the JS files are gone. I'm going to go ahead and run TSC, TypeScript Compiler, just so you can see it with its command line arguments. Great. I'm going to go ahead and run Go. And what you'll see is that it actually will compile my project, and it will listen on port 1337. So now if I hit it from my system here, let's see here, localhost 1337, been here before obviously, and yay, it worked, that's nice. So we can use it on the client, we can use it on the server. The Monaco team that I mentioned has an implementation that runs on Node on the server, has a bunch of code that's loaded in the browser. They have the same code base, but they actually compile with the AMD flag for the Node.js stuff that runs on the server. They run with the CommonJS flag on the client. So there's some same code base, two different compiles, which is kind of one way to handle it. Okay. So go ahead and kill this guy. All right. So last but not least is it might be interesting to actually take a look at an existing project. And so I could say File, New, Project. I'm going to create an empty ASP.NET Web project. Call it GoToCon. Sure, why not? No, I don't save those. I'm going to just say it's an empty project. So basically, I've got the bones of I have a solution, if you're familiar with Visual Studio. I have a solution that basically has property and references to libraries in a web config, and there's nothing else in it. Let's go ahead and import some very simple example. So I'm going to do, was it Control-Alt-A? Well, I probably should show you that. So if you right-click, you can say, I want to add new code or existing items. Let's add some existing items. So this is kind of a super brief scenario of, oh, I have an existing project. I have an existing project that I actually want to port over. So here you'll see I have that's awesome, where'd it go? I have a super simple, I don't need the TS file, I need the HTML page though as well. All right, so I bring these guys in. So here I have a super simple web page, right? So I'm including my JavaScript 1.js file, and basically it's for calculating body mass index, so height in inches and weight in pounds. So just using kind of very simplistic, no style sheet or anything. Who needs that on a day like this? Then we actually have the JavaScript JS file. You'll see it has basically two functions. Oops. Has basically two functions in it. The two functions are one to calculate the BMI, and a second one which is to grab the input, basically get it converted, and set up the result and display it in a div tag that's on the page. Okay, so if I want to actually TypeScriptify this thing, I can just right-click on it, and I can say rename, and I can simply change the extension to .ts. And you'll notice it says, hey, you're changing the extension. It may become unusable. Are you sure you want to change it? I totally do. And then it says, hey, I've noticed that you have a TypeScript project. Would you like to provide information for libraries? So there's a NuGet packet manager. And basically, you'll see that it's searching for different libraries that I could use that are, you'll see tag : TypeScript. So here's one for jQuery. Sure, why don't we go ahead and install that? And here's one for Bing Maps. Sure, we won't use that right now, but why not install it? And then Angular. Oh, there's another popular one. Let's use Angular. Could have used some of the binding stuff that they do in Angular. That'd been kind of cool. So what you'll see is that I now have a scripts directory, and there's Angular, and you'll notice that it has d.ts. So essentially what it's providing there is the descriptions for the type definitions for Angular. And if I look at my project here, you'll see that it's actually giving me a few warnings right off the bat. One of the things it says, not super painful, but the property value does not exist on type HTML element. Oh, okay, that's good to know. Or not on all HTML elements, so I can simply say node, value, and it becomes happy again. And then I could actually come up here and say, hey, I'd like to call this guy, and I would actually like to know the fact that I'm passing it a number. Oops. And that this guy also takes a number. And in fact, this whole thing returns a number. Okay, that's kind of nice. So it basically runs JSLint underneath the covers, plus any errors there are. That's awesome. I'm really happy about that. So it's actually pulling in, for some reason I didn't configure this project right, and it's pulling in additional errors from the libraries I added, which is really awesome. So I'm just going to go ahead and dump those guys quick. Sure. Should cut down on the number of errors. In any case, I actually can, once I've done that, I can actually run this. So if I select the HTML page, and let's just set a breakpoint here for fun. you'll see a couple things get produced. One thing that you'll notice is that there currently isn't a JS file. I don't think there is. Show all files. There currently isn't a JS file in this project. If I go ahead and do the build, what you'll see is that it creates a JS project for me, creates a JS file for me, and it actually, that's what it gets executed. It also creates a map file. And in that map file, it actually maps between the TypeScript code you have and what actually was generated. And what that lets you, in effect, do is be able to debug. That's awesome. 74 errors. Wow. More than lines of code I have. I'll get rid of this one, too. All right, and there's my project, and if I enter data here, I think I had a breakpoint. Of course, this is a lie. I don't really weigh 160 pounds, but you know, when I'm being recorded, let's say that I'm actually really super healthy. And you'll see I can actually step through in the debugger. I can see that I actually did not get a value out of that text field for some odd reason. And as I said, there's actually a map that maps your code to TypeScript so the debugger can actually run. So let's wrap here before the gong hits. So TypeScript 1.0 is in Visual Studio. It's built in just like C# and VB is. It will continue to ship with Visual Studio. It also is available for your download and inclusion in your tools. It could be that your favorite tools already support it. We saw a long list of tools that actually support it. In the PDF that you'll get with the session, there's some great information that's available. So if you have Visual Studio and you're on 2013, Update 2 includes TypeScript in the box. TypeScript, Anders does a talk. He's the language designer of C# and TypeScript. He does a great talk at Build about a month ago. Eric Gamma does a great talk on building large-scale JavaScript applications in TypeScript. There's also TypeScript.lang.org, where I was playing in the playground. There's TypeScript in Codeplex if you want to see what the source looks like or make a fork or a pull request. There's definitely Type for any of the popular libraries you might be using. And then there's WinJS, which is another open source offering from Microsoft, which is essentially Windows API available through JavaScript. That's it.